All right, today we're going to talk about transformations of quadratic functions. So this is what we call our parent function. This is where your vertex is 0, 0. The function hasn't moved up or down or left or right. It hasn't been stretched to get fatter. It hasn't been stretched to get skinnier or compressed to get fatter. And it hasn't been reflected. It's just no transformation whatsoever. And this is all quadratic functions are transformations of this parent function. Okay, so I could look at a graph and I could be like, oh, this one's moved up 3 over 1, or it's gotten long and skinny, and I can find out what all those transformations are. Okay, so this is the standard form f of x, which we know is y, equals a x minus h squared plus k. We know h goes in opposite. Okay, so you must know this. I promise you right now, I will not give this to you like I did the quadratic formula. You must know this. Okay, so if you have a vertical translation, that vertical is up or down. Up or down. So if you look at this problem, what's changed here? Has the h changed, the k, or the a? The k. So the k is my vertical transformation. It tells me up and down. Because look right here. Look at the first problem up here. We had x squared. And now we have x squared plus k. So see, if it had been h, it had been in the parentheses, right? All right. So this means if it's plus 5, it's going to go up 5 because it's positive 5. Does that make sense? Okay, this one's negative 2, so that means I'm going down 2. Do you see how to tell that from there? Now the graph, it should be at 0, 0, right? The parent function. Remember how y'all did this in Desmos a couple of days ago, and I told you we would get to it in a couple of days? Today's that day. All right, so we went down 2. So this one is down 2 also. Okay, who has any questions on up or down? What changes when it's up or down? The k. Okay. Horizontal translation is left or right. And then the thing that changes here is our h. And then be careful with h because h comes out opposite. And then it goes back in opposite. So here, since it's plus 3, it is left 3 because it would be negative 3. Does everybody understand that if it's plus in here, you have to think opposite? Since this is minus 5, it will be right 5. Does everybody follow that? Okay, this one, they drew the parent graph for you. What happened to it? It went 1, 2, 3 to the left and up 1. Is it 1 or 2? Oh, 2. I see that now. Thank you. So left 3 and up 2. Does everybody understand that? So sometimes they could have more than one transformation or translation. Yes?
What is the left 3, right 5?
Where did the what?
Left 3, right 5. Where did that happen?
Here?
Oh, where does it happen?
Yeah, this is one example. This is another example. And I'm saying what happened in the problem. Because my h changed to a 3 here. Good? Okay, so let's keep looking. If a is greater than 1, it is a vertical stretch. My S still looks bad. It stretches, so your parabola is going to be skinnier or taller. If a is less than 1, it is a compression. When you press down on something, it normally gets wider. Or sometimes you'll see the word fatter. Okay, so in this part right here, is it gotten wider or skinnier? Wide. So this one is a compress. And this one here is a stretch. And you practiced that last night in your Delta Math 2. You noticed when the a was less than 1, it was a fatter parabola. When it was skinny, it was tall, and it was greater than 1. Okay? If A is negative, that will cause a reflection across the x-axis. Okay, any questions about the translation? We're fixing to put it into action. All right, let's look at the next page here. All right, so you may be asked to write an equation in vertex form given the description. So if I go up 1, what changes, H or K? K. So this would be f of x equals x squared and then plus 1 because the K doesn't change sign. Does that make sense? Okay, if I go 3 to the left, am I changing H or K? H, right? Left and right's H. So that would be f of x, and then H also does opposite. So since it's left, then it would be plus 3 squared. Because left is negative 3. So what's the opposite of negative 3? Positive. Good? The reflection across the x-axis of fx equals x squared. So if it's a reflection, what's the only thing that changes? The negative a, right? The a becomes negative, so this would be negative x squared. All right, I want you to do 4, 5, and 6. It kind of adds a couple things together. And we're going to go over that. All right, so this is 5 units to the left. The left is H, so that's like negative 5. So it goes in as positive 5. And then down 5, minus 5. Okay, 2 units right, so that would just be positive 2. So it's going to go in as minus 2. And then up 1 plus 1. Okay, 3 units left, negative 3. So that'd be plus 3, and then 2 units up. Questions on that? Okay, so let's look at the next one. Write your problem 7 and 8. Go ahead and write that in vertex form for me. Okay, before I can graph, I need to solve for y. So how do I move this 1? Add 1 to both sides. I get y equals x minus 4 squared plus 1. Yes? All right, what's my vertex here? 4, 1. So I can go over 4, up 1. Okay? I need some more points. Anybody tell me how to get some more points? Change it to standard. Okay, so I'm going to scroll down a little bit. We're going to practice changing this to standard. So I'm going to have x minus 4 times x minus 4 plus 1, x squared minus 8x plus 16 plus 1, x squared minus 8x plus 17. Oh, did that help me any? No. But I can do what? I can put it in the calculator now. I can't factor that. Let me tell you why you can't factor that. So I have x squared minus 8x plus 17. 17 is prime. 1 and 17 won't give me 8. And the other reason, look, let me show you something else. We know this graph is opening up. If it opens up, is it going to give me any factors? No, because where do those factors go across? The x-axis, right? So let's put it in our calculator and somebody give me some points. Because we need to practice that. So we go to our vertex where we're at 4, 1. And then we're going to do a couple on each side. Oh, so we're going to be at 3, 2, and 2, 5. So 3, 2. If I know 3, 2, then I also know 5 is at 2 because I know they're symmetrical, right? Yes? At the vertex. At 4, I'm on the table. I started at 4, 1. I go down to 4, 1. Do you see? Because I always start, where do I always start when I graph these? Vertex. Do you get 4, 1? Yeah. Okay, so then what's beside it? 3, 2, and 5, 2, yes? And then beside that, I know, but then what's beside the, what's 5, 2? Go down to 5. What's 5? 5's at 2 also. You see what I'm saying? And I knew that anyway. If I know 3's at 2, look up here at the board, Cameron. If I know 3's at 2, then I know this is the reflected point, right? And then 2, 5, if I know 2's at 5, then I know the reflected point is at 6, 5. So if I know 2 points on the left, I don't have to worry because I can reflect them to the 2 points on the right. Does everybody understand that? I cannot draw and connect dots with this pen. Okay, everybody good there? All right, so that is the reflection. Let me